right in front.
Yep. All right. So start us off here. What is this great oxygenation event?
Well, it happens, we think, between 2.1 and 2.4 billion years ago, where all of a sudden some of the cyanobacteria that are in those two domains, because there's only two domains at this time on Earth. Remember, life started 3.8 billion years ago. So now we're fast forwarding about a billion 2 years. And these bacteria start kicking out oxygen. And the oxygen is what we call a holocaust. That's the way I like to teach people to do it. And if you understand that the metabolic pathways back then worked quite well in a hypoxic state where, glycolysis specifically, or what I would tell modern biochemists to think of as a Warburg shifted metabolism. And you have to add into the GOE the big story of how sunlight, oxygen, and electricity become central to the understanding of what happens. It's not a mystery. It's not a mystery to decentralized science. It's a mystery to people who think Darwin was right. In fact, the Cambrian explosion, in my view, actually is one of the key pieces that everybody who's a biochemist should stop and say, this makes no sense when we think about what Darwin really taught us. And that's good. That if you have that mindset, this story that we're going to weave is going to be even, I think, more interesting for you to ponder. So anyway, what happens is oxygen tensions for a long period of time go up, down, sideways. They move back and forth. Why is this important? Chlorophyll being the first story, it's basically a porphyrin that magnesium is inside. You have to know that magnesium is periodic table number 12. It's got 12 electrons. The story of magnesium, the reason why it's selected is very simple. It's extremely redox stable. And meaning redox stable means that not even strong light can change, its oxidation state, which is good because that made it perfect for the photostem that basically is tied to the rubisco enzyme, which, very well. What is the key story at this part in the GOE? This is actually how we slow light down, capture its power by increasing the electrical resistance, utilizing mass on this planet. This is called chlorophyll. So that's the first change in electrical resistance that you see. And what happens when light is slowed down like that? You get things called food. So food is an electromagnetic barcode of sunlight that comes here.